Hello once again. Welcome back to Foolish Engineer, where we dive in the world of electronics. Today we are throwing some light on the topic of LED drivers. Whether you are an electronics newbie or seasoned pro, understanding LED driver is important. So let's light up this topic and get started. One of the key reasons I started this YouTube channel is to bridge the gap between outdated Indian education system and actual skills needed in the industry. I'm excited to share that this video is sponsored by Altium. If you're an electronics student in India, you can get Altium Designer for free under its Altium Student Lab program. It is an advanced electronics hardware design platform. It's a fantastic way to enhance your skill and increase your chances of landing a job in core electronics companies. And with its best feature, Altium 365, you can upload projects to the cloud, manage libraries, collaborate, and review with your team. It supports all CAD files, making an electronics design faster and easier. Just use your university email to get started. Plus, you'll receive a student license, a PCB design course, and a certificate recognized by top Indian industries. You also get a free access to Power Analyzer by Keysight. I've personally used Altium Designer since the start of my electronics journey, and I really recommend it. So don't miss this chance. You can get started with Altium 365 by clicking the link in the description. Alright, let's start with the basics. What is an LED? Well, it stands for light emitting diode. It's a semiconductor device that emits light when an electric current passes through it. LEDs are super efficient, long lasting, and comes in all sorts of colors. They are the backbone of modern lighting solutions, from your smartphone screen to giant billboards. LEDs are different from traditional light bulbs in several ways. They don't have a filament that burns out, and they don't get nearly as hot. This means they can last thousands of hours longer than our bulbs. But here's the catch. You can't just plug the LED into a power source and expect it to work like a light bulb. In reality, it is a bit complicated, which is where we need LED drivers. Driving an LED is all about controlling the current that flows through it. You see, LEDs are like perfectionists. They need the current to be just right. If you add too much current, then you'll fry the LED. And if you add too little current, it won't shine as brightly as it can. The simplest way to drive an LED is by using a current limiting resistor between DC source and LED. Remember, LED works only if you provide a positive supply to its anode terminal and connect cathode to ground. It is a type of diode which only works in forward bias. Here is a simple circuit. You have your DC power source, LED, and a resistor. The resistor's job is to limit the amount of current that flows to the LED. This method works, but it's not very sufficient. Imagine driving a sports car with a bicycle brake. It will work, but it will not work very well. The resistor will dissipate excess energy as heat, which is inefficient, especially in high power applications. That's why we use LED drivers. An LED driver is a self-contained power supply that regulates the power required for an LED or array of LEDs. It provides a constant amount of power regardless of fluctuations in input voltage. This ensures our LED have long and healthy life. So, why do we need a constant current source to drive an LED? LEDs are current-driven devices. Their brightness is directly proportional to the current flowing through them. But here is the twist. The voltage drop can vary due to manufacturing tolerances and temperature changes. A constant current driver ensures that LED gets steady current, making our LED's life a lot longer and its performance more predictable. Let's break this down. Imagine you're filling a cup with water from a water reservoir. If the pressure keeps changing, you might overflow the cup or not fill it enough. A constant source is like having a tap that always fills a cup at the perfect rate, no matter what. This is crucial because too much current can overheat and damage the LED, while too little current will make it dim and underperform. Now, let's talk about the different type of LED drivers. There are mainly two types: linear regulators and PWM regulators. Linear regulator is like the slow and steady tortoise. It works by dissipating excess voltage as heat. Linear regulators are simple and provide smooth, steady current, but they are not most efficient for high power LEDs because they waste a lot of energy as heat. But PWM regulators are rabbits of the race. PWM stands for pulse width modulation. Instead of wasting energy, they switch the LED on and off very quickly. This rapid switching controls the average current and hence the brightness. PWM drivers are much more efficient and are ideal for high power applications. We have already seen the constant voltage regulators and switching regulators in many of our older videos. You can check more by clicking on this card. Here is a quick comparison. Linear regulators are straightforward but inefficient at higher power. PWM regulators are a bit complex but far more efficient. We need to choose based on our application needs. If there is a very high power requirement, we should use PWM drivers. If the power requirement from the LEDs is lower, then we can go with a linear regulator. Well, we can control the brightness of the LEDs with such drivers also. It is like adjusting the volume of our favorite song, which is a very handy feature actually. Remember when you are in bed at night, you keep rolling through your Instagram reels, and suddenly you remember that the phone's screen brightness is too high because it's burning your eyes and you decrease the screen's brightness. That's where these LED drivers come into picture. There are two main methods: analog dimming and PWM dimming. Analog current adjusts the current flowing through the LED. It's smooth but can be less efficient and generate more heat. PWM dimming involves switching the LEDs on and off at higher speeds, adjusting the duty cycle to change the perceived brightness. It's more efficient and wisely used in most applications today. And if you're thinking, doesn't that flicker bother us? Well, our eyes can't perceive the rapid flicker if the frequency is very high enough, making PWM a brilliant method. Well, LED driving doesn't stop here. In fact, how we can connect our LEDs also make a huge impact. There are mainly two configurations: series and parallel. In a series setup, LEDs are connected end to end. The same current flows through all LEDs, but the voltage adds up. This is great for maintaining uniform brightness, but a single LED can break the chain, like Christmas lights, where one bulb goes out and the whole string goes dark. But in parallel configuration, each LED or series of LEDs has its own current path. The voltage across each path is the same, but current can vary. This setup is more complex but offers redundancy. If one LED fails, the other keeps shining. It's like having multiple lanes on a highway. If one lane is closed, traffic can still flow through others. Depending on our application, we might choose one or another. Series configurations are simpler and easier to manage, while parallel configurations offer more reliability. So, there you have it, a bright and shiny overview of LED drivers. Remember, choosing the right driver is crucial for your LED project success. Whether you are illuminating a tiny indicator or a massive display, understanding these concepts will help you make informed decisions and keep your project flickering to life. If you're working on your own LED projects, always consider the type of driver, method of dimming, and configuration of the LEDs. These choices will impact the efficiency, lifespan, and performance of your LED. Well, that you have it. If you enjoyed this video, give up a thumbs up and don't forget to subscribe for more illuminating content.